everyone. Since school we are studying chapter 2 solutions. And solutions also we studied Henry's law and Raoult's law. Raoult's law for binary liquid mixtures can be defined as for any liquid mixtures the vapor pressure of each volatile component is directly proportional to its mole fraction in solution. That we studied. Then next is the second type of solutions where a solid is added to a liquid. When a solid is added to a liquid, so if you are adding a non-volatile solid to a liquid, right? You are taking a solution and non-volatile solute is added to the liquid. So when only liquid is there is vapors, only vapors of liquid is present on the surface of this liquid, and the pressure exerted by this liquid on its surface is P1 naught. Now we have added a non-volatile solute to this liquid. So when non-volatile solute is added to this liquid, the non-volatile solute get dissolved in the solution, and on the surface also there will be moles of this non-volatile solute. So the number of moles on the surface of the on the surface for the non-volatile solute increases, and therefore number of moles of volatile component decreases or volatile liquid decreases. So as the number of moles of volatile liquid decreases, this vapor pressure of this solution also decreases. You can see that this vapor pressure is directly proportional to the number of moles of the solvent or number of moles of the volatile component which is present in the solution. As the number of moles of volatile component decreases in solution, vapor pressure also decreases, and now we can call the vapor pressure of this solution as P1, or it is called partial vapor pressure of the solution. So according to Raoult's law, P1 is proportional to X1 or P1 is equal to P1 naught X1. This is for a solution containing a volatile liquid and a non-volatile solute. Now in general form. So this is earlier what we studied was for Raoult's law for the binary liquid mixture containing two volatile liquids. Now this is for a solution containing non-volatile solute in a volatile liquid. So in general way we can define Raoult's law as for any solution the partial vapor pressure of the solution is directly proportional to the mole fraction of the solvent present in the solution. So again, so if we are adding this vapor pressure is purely depending on the mole fraction of the liquid. So if you are adding 1 mole of urea or if you are adding 1 mole of glucose, the number of moles that comes to the surface will be same as the number of moles of solute which is coming on to the surface is same. Then the depression in this vapor pressure. So vapor pressure is decreased, P1 is less than P1 naught, and this depression will be nearly similar if we take 1 mole of glucose or 1 mole of urea. Now this is P1 is equal to P1 naught X1, and based on Raoult's law we can classify the solutions into two types: ideal solution and non-ideal solution. Next we are going to study about ideal solution and non-ideal solution. Now ideal solution means a solution which obeys Raoult's law at all the concentration. So P1 is, if we are taking a liquid mixture containing two volatile components, P1 is equal to P1 naught X1 and P2 is equal to P2 naught X2. So for this, if a liquid is obeying Raoult's law for all the compositions, then that is known as ideal solution. And if it is not obeying, then that is known as non-ideal solution. Then examples for ideal solution. So ideal and non-ideal solution. Examples for ideal solution are N-hexane, normal hexane. N means normal hexane and normal heptane. This is then chloroethyl, and bromoethyl. Benzene, toluene, and toluene. So, if we take these mixtures, this will obey Raoult's law under all the compositions, and this solution is known, these solutions of these are known as ideal solutions. Now, we said ideal solution, if it is ideal solution, it will obey Raoult's law. Now, it will obey or it will follow to another conditions also. For ideal solution, delta H mix will be equal to 0. Now, and delta V mix will be equal to 0. Now, what is meant by delta H mix and delta V mix? This H term delta H, you know, that is change in enthalpy. That is, or change in energy. So, when we are mixing two solutions, for example, if we are mixing normal hexane and normal heptane, there will not be any change in energy. So, or next is delta V mix. Delta V mix means if we are mixing 10 ml of hexane and 10 ml of heptane, so we will get 20 ml of solution. So, before mixing 10 plus 10, the volume was 10 plus 10, 20 ml, and after mixing also the volume is 20 ml. So, delta V mix will be equal to 0. Then, if a solution is ideal solution, it will also follow these two conditions. Delta H mix will be 0. That means no energy will be liberated. Temperature will remain same. And delta V mix, volume will not change. Volume before mixing and volume after mixing will be same. So, this is about ideal solution. Now, next is non-ideal solution, which will not follow this Raoult's law of over all the conditions of all the concentrations. So, then what is meant by it is not obeying ideal behavior. We said for solution, for ideal solution, P1 will be always equal to P1 naught x1. But if it is a non-ideal solution, then this P1 will not be equal to P1 naught x1. P1 will not be equal to P1 naught x1. P1 can be greater or P1 can be less than P1 naught x1. Then that is called negative deviation. Next is what is reason for positive and negative deviation. Then there are two types of negative deviation. Negative deviation, positive deviation is there, and negative deviation is there. First we will study what is the reason for ideal behavior. So we are taking two liquids, A and B. These are pure liquids. This is A and this is B. Now this vapors of A is there on the surface of A. That pressure exerted by this vapor is P1 naught, and on the surface of B there are vapors of B, then the pressure exerted by these vapors is P2 naught. That means P1 naught and P2 naught are the vapor pressure of component liquids A and B respectively. Now we are going to mix these two solutions together. So now we got a solution, that is AB. So this is solution AB. Now on the surface of this solution there is vapors of A and vapors of B. Vapors of A is there, vapors of B is there. Now the pressure exerted by vapors of A is P1 and the pressure exerted by vapors of B is P2. Now if P1 is equal to P1 naught x1 and P2 is equal to P2 naught x1, then we will call this as an ideal solution. P1, this P1 is equal to P1 naught x1 and this P2 is equal to P2 naught x2. So what we will call this solution? We will call this as ideal solution. Now what is the reason then? If it is these are not equal, so then then we call it as non-ideal solution. Now what is the reason for the ideal behavior? When liquid A is there, in A there are molecules of A. There is force of attraction between these molecules of A. That force of attraction can be called as A interaction. And in liquid B also there is force of attraction between molecules. That force of attraction can be called as B interaction. And after mixing inside the solution, there will be force of attraction between A and B or AB interaction. So new interaction is for AB interaction. So if the force of attraction between AA and BB is equal to AA force of attraction and BB force of attraction is equal to AB force of attraction, then the solution shows ideal behavior. If these two interactions, initial interactions are not equal to AB interaction, then it will show non-ideal behavior. It will show deviation from ideal behavior. So what is the reason for ideal behavior? The force of attraction between A and B, or the new force of attraction AB formed is equal to the force of attraction formed between AA and the force of attraction between BB. Now next is deviation from ideal behavior. So there is positive deviation and there is negative deviation. Positive deviation and negative deviation. So two type of deviations are there, positive deviation and negative deviation. Now what is meant by positive deviation and what is its reason? Now if we take positive, then we have mixed these two liquids together, A and B together. Now if A-B interaction is less than A and B interaction. So this AB interaction inside the solution, AB interaction is there and this AB interaction is less than AA interaction and BB interaction. Then what will happen? The force of attraction between these molecules are reduced. Reduced means these molecules will easily get evaporated. And the solution will be more volatile than A and B. So force of attraction is less, these molecules are easily evaporated and the solution will become more volatile than A and B. When it becomes more volatile than A and B, vapors formed on the surface will be more and the pressure, that is P1, will be more than P1 naught X1. P2 will be more than P2 naught X1. This is known as positive deviation. So what is reason for positive deviation? The reason for positive deviation is the less force of attraction between A and B compared to force of attraction present in A and B. Now examples for positive deviation is acetone and carbon disulfide, CS2. Acetone and CS2, carbon disulfide. Acetone, you know, that is CS3, C double bond or CS3. Acetone and carbon disulfide, both are organic molecules. Both there is dipole attraction. In CS3, C double bond or CS3, there is dipole attraction, and CS2 also there is dipole attraction. So if we are taking acetone as AA, then the force of attraction with AA force of attraction is dipole, and if CS2 is B, the force of attraction, BB force of attraction is dipole force of attraction. When these two are mixed together, new force of attraction is formed. Between these two, new force of attraction will be formed. That new force of attraction is also dipole force of attraction. But this dipole force of attraction is weaker than initial force of attraction. This is weaker than the force of attraction present in acetone and CS2. So the force of attraction is weaker, then what will happen? Acetone and CS2 will easily evaporate than when they were alone. So the vapor pressure will be increased and it will show positive deviation.